Okay, so the big idea today, our learning objective, our learning target is find the area bounded between two curves. Doesn't matter. So instead of looking at the area just bounded beneath the curve and the x-axis, we want to find the area between the two curves. Now, this isn't that challenging, which is why we're going to cover 2 days of this, tomorrow and today and Friday. Okay. And then next week, we'll kind of relax. It sounds like you guys have a very busy week for final exams. I will let you prepare for mine on Wednesday. On Monday and Tuesday, we are not going to have homework, but I expect you to be working on stuff that we're doing in class. If you don't, you'll make me very upset because I could just move on to other material. I'm trying to accommodate your lives. So make sure you use my time wisely on Monday and Tuesday. On Wednesday, I don't care what you do. Yeah. That's one way to think about it. Unfortunately, the sine curve doesn't really make a nice sector portion. So if you see repetition, you can double it, triple it, quadruple it, and I will do that later on in this course. In this situation, if we want to be able to find the height, notice the rectangle that we have right here. If I were to draw a rectangle to represent the area, again, when we do stuff like this, we draw an infinite number of rectangles. I'm not going to draw an infinite number because that's impossible, but I'll draw 3, okay? You can see that the height of this rectangle is f of x, right? And then this has a height of g of x. So do you know what the height would be of the rectangle between there? Yeah, if this was a height of 10 and this was a height of 8, then the green portion would have a height of 2. You just subtracted them, right? You took the top minus the bottom. So first of all, the formula for area bounded between the two curves will be the integral from a to b of f of x, meaning that f is the top function, minus g of x being the bottom function. But then there's one other thing that I want to write, and you guys were leaving it off of your last test. And I get it, and I didn't mark it wrong on the test, but there's no excuse now. It has to be there because it's extremely important. Look at this width. That width we try to make infinitely small, correct? This width, is it horizontal width or is it vertical width? It's horizontal width. And we say that that width is represented by, when we did Riemann sums, we said delta x. Here we say dx. That represents the width of the rectangle. So when you draw your rectangle, you can see it as horizontal width. What does that mean? It means that the function has to have an x variable in it, and it means that our bounds are also x values. Tomorrow we're going to look at vertical width, dy, and that will change the way that we operate. So you need to know how to do both, okay? So everybody got that basic piece? Okay, let's flip it over and we'll at least draw the function. We're going to quick change the problem. Should be from 0 to 1. Find the area bounded between y equals x squared and y equals negative x plus 4 over the interval 0, 1. So first thing you should be able to do all the time, if you have to use your calculator to do this, so be it, but we need to know what the shapes look like. So what does x squared look like? That's that parabola. I'll draw it in red. And then what does negative x plus 4 look like? That's, yep, going down and it's up 4 units, something like that, right? We'll pick up with that when we get back. Go get some brain food and shake off that test. All right. What is the top function here? What is the function that's on top? If I draw my rectangle right here, you can see that this is the top function, negative x plus 4, and the bottom function is x squared. And this width, the width of the rectangle is dx. So if the top is negative x plus 4 and the bottom is x squared, I subtract the 2. And it tells me my boundary is from 0 to 1. So the integral is going to be from 0 to 1, negative x plus 4 minus x squared, and the width is dx. It's extremely important that you put that dx there. It will be counted wrong on the test if you don't have that there. There are times where people put a dy here, but they have x included. That's not correct. You want to make sure that these bounds are consistent throughout, or that x is consistent throughout. So I take the antiderivative. What's the antiderivative of negative x? Negative x squared over 2. What's the antiderivative of 4? 4x. What is the antiderivative of negative x squared? We're going to evaluate from 0 to 1. If you plug in 0, you get 0 in this situation. So I just have to plug in 1. We get negative 1/2 plus 4 minus a third. Common denominator would be 6. So negative 3/6 plus 24/6 minus 2/6. That will bring me to 19 over 6 is my final answer. Some of the problems for this test you'll be asked to do by hand. Others you'll be allowed to use a calculator. What do you think? Number 2, find the area bounded between the curves y equals x squared minus 2x plus 1 and y equals 2x plus 1. What's different about this problem compared to the first one? You're not given any bounds. So there must be an area that's completely enclosed by those two that we're trying to find then. If I draw my shape, because I had a really, really good college algebra class, I remember that this factors to x minus 1 squared. So the vertex is 1, 0. And so I know the shape of this parabola very well. And so I had a really good 8th grade algebra class. I know that 2x plus 1 is a line that passes through 0, 1 and has a slope of 2. And so there's my graph. Is there a region that is completely enclosed by these two? Yes. And so I'm going to draw a rectangle to represent the area. That rectangle has horizontal width, which is referred to as dx. So I know that's my setup. What is the top function? 2x plus 1. What's the bottom function? And I just need some bounds now. Anybody got some good ideas? 0 would be 1. Let's do it by hand. What am I looking for? The intersection point. And I'll solve for the intersection point by simply setting them equal to each other. Go ahead, D. Weiland. They recognize by looking at the graph, my graph isn't drawn very well because my smartboard orientation is a little bit off here. If I drag that up a little bit, you can see that they both have a y-intercept of 1, an x value of 0. We want the x value, not the y value. So we are integrating or drawing rectangles from this spot over here all the way to this spot up here. So we want to know those x values. Yep. All right, so let's solve this. I will Subtract the 2x and subtract the 1, and I get x squared minus 4x is equal to 0. So it looks like the other bound is 4. Does that look reasonable by looking at your graph? Sure. So should I take the antiderivative or should I simplify first? Let's simplify. The integral from 0 to 4, 2x minus the negative 2x would be 4x. Those are gone. 1 minus 1 is 0, and I have a negative x squared. Okay, so what now? Antiderivative of 4x, I get 4x squared over 2, or 2x squared minus x cubed over 3. If I plug in 0, I do get 0. If I plug in 4, I get 4 squared is 16 times 2 is 32 minus 64 over 3. Or 96 over 3 minus 64 over 3 is 32 thirds. What do you think? Not too bad? Let's try one involving trigonometry because I know how much you love trig. And we will end with this for today. We'll pick up the other piece tomorrow. It says find the area bounded between the curves y equals sine of x, cosine of x, and then over the interval 0 to pi over 4. So what does the graph of sine of x look like? It's a wave, and it starts at 0, and it goes up to 1. So what's that? Yep, 0 to pi over 4. I'm going to draw the whole graph just so we can get an idea for sure of what it looks like. There's a rough sketch. How is cosine different? Yeah, it starts at the top. So I'm going to guess that the region that they're referring to in the problem is right here. Do we know for sure that they intersect at pi over 4 and that it's not further? Because notice the problem. Right now, which function is on top? Cosine is on top. What function is on bottom? Sine. But if I were to move over to this region, it switches, doesn't it? In that case, you would have to switch the integral then. You would have to set up 2 different integrals. So hopefully that spots pi over 4. We should verify. Let's say sine of x is equal to cosine of x and see where they intersect. Okay. D. Weiland confirms that it looks right. We'll verify mathematically. Do you remember from trig how we solved this? Divide by cosine. Good. And you get tangent is equal to 1. What would we do next? We could inverse, and on our calculator, when we inverse tangent of 1, you get 45 degrees, which in radians is pi over 4, which is what we have. Tangent inverse of 1. So Dylan's eyeball is very good. Nice job. So I'm going to integrate from 0 to pi over 4. of cosine of x, which is the top function, minus sine of x, which is the bottom function, dx. What is the antiderivative of cosine? Sine. Antiderivative negative sine, positive cosine. Here's a mistake that sometimes people will make on this, on these problems, on this test, is that when they see 0 at the bottom, they'll just assume, well, that will be 0. Well, not for cosine, right? Because the cosine of 0 is 1. So be careful, especially if you get some trig values popping up there. I plug in pi over 4. Fortunately, you had an awesome trig experience. You remember exactly what the sine and cosine of pi over 4 is, because what's the terminal point for the angle pi over 4? Root of 2 over 2 and root of 2 over 2. Good. So the sine of pi over 4 is the root of 2 over 2, plus the cosine of pi over 4 is the root of 2 over 2. Minus, what's the sine of 0? 0 and 1. What's the root of 2 over 2 plus the root of 2 over 2? Root of 2 minus 1. And that's the exact area. Just kind of cool. 0.41. Your assignment is 6 problems. I know the homework bug jumped up and bit some people last time. Even though you may have gotten your homework done, you maybe weren't able to really ensure your learning or allow it to imprint on your brain. I never feel good when we have 25% of the class scoring a 63% or lower. But all we can do is control what we can control. And what you can control is doing your homework on time and then trying to ensure that learning by then preparing with the study guide. Problems 1 and 2 and 5 through 8 in the book. I did notice that this last unit we only had 1 worksheet. And so I know that we're less likely to check our answers if we don't have a worksheet. You'll have worksheets for the, you'll have a book assignment tomorrow, but then when we get done with third quarter, the rest of your assignments for this unit will be worksheets. But please, try to make sure you're checking your answers. It's a good thing. It's a good thing, okay?